Okay, let's get started. Okay, so I'm finally getting around to talking about structs. And it took a while because my first attempt was I just did it too early. There were a few concepts that we needed to touch on. So let's take a quick overview of what we've done in the past. So in the past, we created a character, um, and that character was based on abilities. So this is back from a previous video uh, where we defined an ability to be a type of integer and a character to be a collection of these abilities in a slice. In the last video, I went in greater depth over slices, but basically we said an ability is the score that we randomly generate that from random roll, and we package 6 of these together in a slice, and we're going to call that a character. And as a convenience to be able to, if we've got a fighter or a magic user or whatever, we want to pick the best score and use that as that character's primary stat. So we put in the ability to sort um, the values, and then we can just get the best value because it's the one at the end of the array, the largest value, or the end of the slice, it's the largest value. And we did this by implementing the members, the necessary interface for sort. Okay, so here we have our ability, which is a subtype of integer. We define a modifier function on it to return back the modifier given a raw value for the ability. What's the modifier for a roll, like a perception check? And then what we did is we put together a collection of these abilities to form a character. We created a constructor to build a character and put their best score last. And we implemented the necessary functions to enroll our character type into the sort, into the standard library sort capability. All right, so let's talk about the problem with defining a character this way. So we can use slices, but that means a character, or that means we can only store the same thing in a slice. So a character has other things too, right? A character has a name. We can't store a name in here because this is a slice of abilities. Um, we can't list the character's competencies or proficiencies. Character also has an inventory and blah blah blah. So this is limited. A slice as a type, a base type for something, is limited to having a collection of things that are all the same. Well, what about a map? So the last video we went over maps a great deal. We could make this a map, but again, of the map, everything has to be of the same type. So you could have a map from, say, strings, where the string is the name of the ability, like strength or constitution or dexterity, and that's how we identify the features of the character. But again, you're limited to a map of strings to abilities. All right. So we need a way to package stuff that is not the same thing, but is part of the same concept, and that's a struct. It's what's called an aggregate type. So let's go back to this, and we're going to go ahead and rename this so it doesn't interfere with oops, rename symbol, so it doesn't interfere with the rest of our stuff. We're going to call this old character. Okay, and so we see that it has renamed everything, so it's not going to interfere with the stuff we're going to do today. So we want to define a type called character, and this type is going to be a struct. And let's start building the struct piece by piece. So we're going to start And a character has a name, right? So the name is going to be a string type. Then it's going to have some abilities. So the strength, dexterity, constitution, wisdom, intelligence, and charisma are all abilities. Right. So let's actually break this up so it's a little bit more readable. Rather than putting all of them on the same line, we can split these over multiple lines, and it's not going to have uh, any real impact. But having them all on one line means that the types are way over the right hand, so it might be harder to read. So this is going to be an ability. This is going to be an ability. This is going to be an ability. And just let me move this over here so that we can be aware that we've got this import. Whoops. Well, it's really going to just stick it in there, is it? Oh, that's right. We don't need that there. Okay. So yes, the ability is defined here. It's not. I was going to move it in a video to random roll, but I haven't moved it to random roll. But here we have ability, and so we're using that definition of ability, and I just copied this data, this code in from the previous Get Going 05 video. Yeah, we don't. This is. I am going to move this to the random roll package, but for now it's here. So okay. So we've got, and let's add something else. Let's add, I don't know, what should we add? Let's add age, and age is going to be an integer. Okay, so we see that unlike a slice or a map, we have different types here. Here we have a string, we have some abilities, and we have an integer down here for age. What makes this like a map is the sense that they kind of are named, right? So a map has a key, but the difference is a key could be like any value of that key value. So if we had a key like a string, it could be any string that we try to get. Here we're limited to just the names defined on the character struct. Now, that's great. So this is a struct. We still need to fill it in, right? So when we're dealing with things like structs, we can look at the standard library as a good example of how we think about them. So for example, these first two functions here return a type D. So this is for type DB. They return a type DB. So these are what are called constructors. So they build us a DB and return to us a DB. The rest of these functions, as you can see, they're methods defined on DB, and so they are definitely part of the type DB, but whereas these are returning a DB, these are methods on a DB, but they're all part of the DB type. So when we think about this stuff, we think of open and OpenDB as constructors to that type, even though they're not defined on that. Even though they're not a method, they're a function. They're not a method defined on that type. They are the constructors of that type. So they're really part of that type, right? So let's talk about our character constructor. So let's call it func make character. What do we need to know? Well, in order to make a character, we need to know what their name is, right? So we're going to pass in a name, and that's going to be a string, right? The next thing we might need to know is how many dice or is our dungeon master going to allow us to roll. And we'll make that an integer. And finally, we need the age, which is an int. Or maybe we say, yeah, let's make that an int for now. And this will return back our character. All right, so we've got our constructor, so let's fill our constructor in. So we're going to return character, and their name is going to be name, whatever we pass in as name. And then that is going to be roll a stat and max dice. And let's go ahead and copy this. We're just going to repeat it in multiple places. We're going to say strength, dexterity, constitution, wisdom, intelligence, charisma, and age. What happens if we don't fill in a value for this character? Well, this initializes a character to these values. If we don't provide a value, the system assumes a zero value. So this is returning a character, which we're initializing to have these attributes. And so we could say C equals make character glub for D6, and glub is age 32. So what do we want to do with glub? Well, we can go ahead and hello. And this is where we can refer to a field in character as the variable holding the character dot, excuse me, the field name. So if we run this, okay, it's not here or there. Let's go ahead and new terminal. So go run dot. Okay. Hello, glub. All right. But you know, one of the things we like to do with characters is we like to print them out. So let's start by implementing stringer. So stringer is an example of one of those methods that when we define it, stringer is an interface that has a single method. It's the method of string. When we define a string method on our type, we kind of enroll into that interface. So let's go ahead and now we're going to define this as a method on character. So we're going to say C is character and string return func.sprintf, right? And we're going to say %s, and we're going to use c.name for that. And then we're going to say s %d, strength, dexterity, constitution, wisdom, intelligence, charisma, and we're not going to bother with the age. So we're going to say c dot strength, c dot dexterity, c dot constitution, c dot wisdom, c dot intelligence, c dot charisma. Okay, why are we getting the red squigglies? Oh, because we didn't tell it we're returning a result string. Okay, great. And just because constitution starts with a C and charisma starts with C, let's put an R there. So now we can say hello, and we can say just C, right? So now if we run this, we can see hello, glub glub, and their strength, dexterity, constitution, wisdom, intelligence, charisma. Okay. So that is enrolling our character, our character type into the stringer interface so we can convert it to a string easily. So I want you to note something. So look at the definition that we used to declare ability. We said the type, then the type name, and then at the end of it, we said the type of the thing. So we declared ability as a new type, and it's a type of integer. We declared old character, and it's a type of ability. And if we go back over here, we have a type and a character, and it's a type of struct. So really, it's almost as if this is, you know, everything is equal. So even though we define our structs ourselves, and they're open for us to define any kind of aggregate type we want to, really it's the same underlying type system that governs everything. So it really is very much that everything is a first-class type in Go. All right. Now, here's a problem with our constructor, right? Our constructor doesn't take into account our um, the fact that our class. So we can go back and we can say, well, we need to add a class, and what should a class be? Should a class be just a string? Maybe not, but maybe we should define class as maybe it is a type of maybe it is a type of integer, right? And we have some classes, so we're going to define a constant. Constant is fighter. That is a class. And actually, let's not use class because that can be confused with well, no, not really. You can use class. And let's say that equals 0. Cleric class equals 1. Wizard class equals 2. All right. Just like we defined the toString on character, or the string on character to enroll it in the stringer, we can do the same thing on class. We can say fighter and case cleric. Those are we'll return string, right? And for this, we have to provide a default, or we can't provide a default, so we don't have to worry about we need to return a string. So if the string is something other than one of these three, we have to return something. So we're just going to go ahead and return the empty string. And we don't need case in front of the word default. There we go. Okay. So we should probably pass in our class. And let's make it an attribute here. So we're going to say his class is a type class. Okay. And again, we get the 0 value, which would be a fighter. So we're going to say class. And we're going to set that to class. Okay. Now we also need an alignment, right? So let's make, we've got class here. Let's make alignment. So alignment, remember an alignment is two parts, right? There is there's whether or not you're lawful or chaotic, and whether or not you're good or evil, or neutral in either case. So we've got type alignment, and let's go ahead and make this into a struct, and we're going to have what do we want to call? The first one is lawfulness, and we're just going to make that into a string, and we're going to make the next part goodness to a string. Okay. Let's see if we can define some constants for this. Lawful good. It's a type of alignment, which is equal to lawful good. Might have to specify what kind of struct it is. Invalid constant. Okay, we can't make a class as a constant, so we're just going to make these variables. So we've got lawful good. We've got, let's just do a couple more. We've got chaotic good. And we've got, say, neutral good. Neutral good. Neutral good. See how I keep misspelling neutral? Well, we wouldn't want that, so we might want to turn these into constants as well. So we could say const lawful neutral chaotic and what do we want to call the other one? Good and evil. So we can replace these with constants, so I don't have to worry about my spelling. If I misspell the constant name, like neural, I get a red squiggly because there's nothing defined with that name, so I would have to. And I get the nice autocompletion, so whoops. So sometimes the autocompletion isn't all it's cracked up to be. There we go. So we need to have an alignment, right? So in this case, the type and the excuse me, the type and the attribute of the character have the same name, but we could have called this something. We could have called this Barbara, right? It'd be silly to call it Barbara, but we could have called it Barbara. It just happens to have the same name. The field in our struct happens to have the same name as the type that we've defined for it. So we can see that a struct can contain strings, it can contain user-defined types like ability, it can contain integers, it can contain constants we define, like our class here, and it can take alignments. We can even make class, really class should really be a slice of classes, right? Because you could be multi-class. And so maybe we need to make that a slice, or we can move it to the so there we would need to add these. Yes, we would need to add let's fix that up because now we're saying it's a slice. We would need to add additional things as appropriate here in our constructor, or we could define what's called a builder. So let's make this legit now, max dice, and we're going to say they are fighter. Yeah, 32. We could also do something related to a constructor called a builder, which is if we kept adding things to this constructor to initialize the character, eventually we'd get like this ungodly list of things. So we can have a builder function which allows us to build up the character over time. But the point being is that the character struct can contain multiple different types of values. And when we think about the character struct, or we struct, and we think about it as a data type, we think of both the structure definition, right? And we think of the constructor that builds the thing, and any of the methods that we define on it. So in this case, we've only defined one method, the string method, but we could have defined our own custom methods too, right? So we could have said func character perception check, and let's say it's a Boolean, and it's just for sake of argument, we can just say it is in intelligence dot modifier plus random roll d20. So modifier, whatever modifier the person has, random roll d20, and we are going to say greater than 10. So I'm not sure that the perception check logic here is legit D&D, but we could you know generate our own methods that we have on here that are part of character, as well as the ones that we implement from existing interfaces. So that's it for structs, and I think you'll now understand why I wanted to cover a whole bunch of other stuff before structs, because structs are all about putting the other types together into a thing. So until we cover the other types, it's kind of it's tougher to cover structs. And yeah, structs are a little bit about the ecosystem around that struct, which is the function that constructs it or builds it, and its member methods. And so that's what I wanted to cover in this video, and I think I did it all right. I think I did it better than my first time through. But anyway, that's it for today. And we'll cover stuff later on. Next time, I'm not sure what I'm going to cover yet, but I'll try to make it interesting.